My name is Bryan Millis, and I'm a senior research specialist here within the Center of Excellence, which is under the umbrella of the Cell Imaging Shared Resource, which is run by the director Sam Wells, and as well as the scientific director Matt Tiska. We're very excited at Vanderbilt University to host the Nikon Center of Excellence, which is actually one of only a few locations in the country, and certainly only a handful around the globe, to feature really the highest end instruments available to us commercially as far as microscopy systems. It really affords not only the research faculty, but the staff, as well as the students, most importantly, access to instrumentation that's very rare to have in one single place. Within the Center of Excellence specifically, we offer three flagship instruments, the first being a very flexible spinning disc and latest generation spinning disc confocal microscope, which really targets understanding cells in their live environment. With this particular microscope, it allows us to sample cells from an imaging standpoint at very high speeds. In addition, we can do this in multiple dimensions. So when we go back through and try to answer various biological questions, we can analyze their live cell dynamics in 3 dimensions in multiple channels, which is very powerful from a research standpoint. And in addition to this, we actually have a targeted laser which we can introduce in this system to either stimulate or even cut cells at subcellular precision. We actually feature 2 super resolution microscopes within the Center of Excellence. The first being a structured illumination microscope, which is very exciting because super resolution has been a buzzword in the last few years, and its development continues. With SIM, we can answer both live as well as static questions, meaning the cells are fixed or they can be live on this particular microscope. And we can answer a whole host of questions with the ability to resolve structures at twice the resolution limit that we can traditionally get from confocal or wide field technologies. So the STORM system, or the STORM platform, also known as stochastic optical reconstruction microscopy, offers us an ability to resolve structures within cells down to 20 nanometer resolution, which is quite exquisite when we think about subcellular structure. This is technology which has been rapidly kind of evolving over the last few years with many different iterations of this particular technique, which we can address on this platform in a very exciting, I would say, addition to the Center of Excellence here. We support all of the acquiring systems of the platforms here with various offline tools. So the first of which are several workstations, which are very high-end computational systems to offer image analysis, signal processing, as well as a variety of softwares to answer and present data for the students and faculty here on campus. So we anticipate that this center, as it currently is generating a tremendous amount of data, and with that comes the burden of managing all of this data. And so we have an infrastructure in place from a networking standpoint to deliver all of the acquisition data from each system in real time to a server, which we then allow all of our researchers and users on campus to access from their desk or remotely. So what we can do then is have data redundancy with various cloud syncs like Dropbox, where we can offload that data to for more long-term storage. We've enjoyed a pretty rapid rate of success here after opening the Center of Excellence, in the sense that many of our systems are booking out now for several days, if not a week or 2. And we owe this to the popularity. We owe this popularity simply to the power of the systems and what they can accomplish. And I think what people are finding right at the get-go is that they're being able to see things both temporally in time, or being able to sample at a rate to expose or reveal various biological processes that haven't been observed before. And from a spatial standpoint, with our super resolution systems, students and faculty are being able to resolve structures that they haven't been able to see previously, which is incredibly powerful for their research projects. Our student user base is growing by the day, and within the center we have a couple of goals, and one of those is not only generation of data. Of course, generation of data in and of itself is fundamental to any research project that a student or faculty member may embark on. But one of the things that's critical for us, not just in the Center of Excellence, but within the larger cell imaging shared resource, is learning, making sure that our students and users, for that matter, understand what's behind the technology, and not necessarily just learning what buttons to press, but also learning what those buttons are doing. And once we build kind of a foundation of kind of a conceptual knowledge, it really translates almost immediately into a really exciting back and forth and exchange of ideas where students understand what the technology can do for them and their scientific projects. And we have many tools at their disposal, like ultra high resolution interactive displays where we can exchange ideas and brainstorm, whether it be with the staff, the scissor staff, or whether it be with their own PIs. It's a lot of fun from both standpoints of mentor and student. Quite a number of years ago, during my graduate studies, where I studied infectious disease, imaging and microscopy became kind of a critical component to understand some of the processes between hosts and pathogens. And during that process, I realized that the technology just kind of clicked with me, and I really had a lot of fun with it. And in that process, I interacted with various microscope companies, and I actually ended up taking a position as an imaging specialist for Nikon, where I worked for 5 years before doing a postdoc at the National Institutes of Health. I then followed that up with a second postdoc here in the laboratory of Matt Tiska. And when the opportunity came up, when I found out that we were adding more systems to the capabilities here on Vanderbilt campus and that this center was going to become a possibility, it was a very exciting time to kind of be involved on a more day-to-day basis with a center like this.